This is the Industrial Alarm and Monitor Hub, one place to watch the values that matter across an entire plant. Before anything else, this system only monitors and alarms. It never controls. It doesn't start a motor, doesn't flip a valve, doesn't write anything back to a machine. It reads, it evaluates, and it warns. That's deliberate. A monitoring layer should never be able to become the thing that breaks the process it's watching. Here's the idea. Every machine in a plant already has its own HMI, the panel right beside it, showing the operator all of that machine's tags. But step up to a central control room, and the dispatcher there doesn't need hundreds of signals from every machine. They need the few that matter, a handful of critical values from each line, gathered in one place. That's what this hub is, a higher layer of monitoring. You choose only the most important tags, and only those show up here, and it connects through the three most common industrial protocols: Modbus, SNMP, and OPC UA, the ones almost every PLC and device already speaks. Each one is a separate plug-in driver, so the system is never locked in. When another protocol is needed, say a native Siemens S7 driver, it's added as one more module and nothing else changes. And you don't need an engineering license or a vendor toolchain to set it up. No TIA portal, no paid software, nothing to install on your PC. Basic automation knowledge and a web browser are enough. Every single thing you'll see is configured right here in the web interface. Here's how. In the admin section, you add a device, pick the protocol, enter the address, and it's connected. Then you add tags, the individual values you want to watch: a temperature, a pressure, a flow, a pump's run state, a compressor's mode. For each tag, you set its unit, its scaling, and a readable name. It's just a form, no code, and nothing downloaded to the controller. For any tag, you define alarm limits: high, 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 low, and low, low, each with a priority and a delay. And this is the key idea. You set these alarms here in the app without ever touching the PLC. You don't open the machine's program, you don't change a line of production code, and you don't need the original vendor. The alarm logic lives in the hub, completely independent of the control system it's watching. This is what the operator sees: live values in clean faceplates, the number, the unit, the limit lines, and a little trend spark line. Click one and it opens a full history chart. Last 15 minutes, an hour, a day, a week. Every value is archived, so you can always look back, compare, and export the data. When a value crosses a limit, an alarm fires. The engine follows ISA 182, the process industry alarm standard. An operator has to acknowledge it, so nothing ever disappears silently. And the alert reaches you two ways: an audible tone right in the browser, and an email straight to the people responsible, so a problem doesn't just sit on a screen that nobody's watching. Three roles keep it safe: administrator, operator, and viewer. Each sees exactly what they should. Under the hood, it's built to OWASP and IEC 62443, encrypted connections over HTTPS, account lockout after failed logins, and an audit trail of every configuration change. The hub isn't a dead end either. Through its own OPC UA server, any higher-level SCADA can read our processed values and alarms. The whole interface is responsive: a control room monitor, a tablet, a phone, and it installs to the home screen like an app. And it all runs on a compact DIN-rail industrial computer, a Waveshare IPCBOX built around a Raspberry Pi Compute Module 5, with the entire application written in Python. The Industrial Alarm and Monitor Hub, the values that matter, from any machine in one place. No licenses, and fully under your control. Over the coming weeks, I'll be releasing short videos, how I build the Alarm Hub, walking through the whole thing step by step, the hardware, the software, and every feature you just saw. And a big thank you to Waveshare, who provided the IPCBOX unit that made this project possible. Follow along.